I'm going to describe how to code a binary classifier using Python. The model we're going to code is to predict whether someone has diabetes, so it'll be predicting yes or no. The features input into the model will be the body mass index, their smoking history, and a measure called HbA1c, which is an average of their blood sugar levels for the last 2 to 3 months. There are different types of classification models, such as logistic regression. We're going to code a random forest. A random forest is composed of multiple decision trees, which have been generated by the model, which are all slightly different, and uses voting to decide on the target classification, whether the person will have diabetes. First of all, you'll need to install the following Python libraries: NumPy, Pandas, scikit-learn, and imbalance-learn. You can download from Kaggle for free the diabetes prediction dataset. You'll need to do the following imports: pandas, train test split, random oversampler, random forest classifier, as well as accuracy score and classification report. We start off by reading the CSV dataset. Here I'm selecting smoking history, HbA1c level, BMI, and diabetes fields, excluding other fields from the dataset. These are loaded into a data frame. I then filter the data frame so only data points with smoking history equal to never or current are included. Smoking history is a categorical variable. I check whether the dataset is an imbalanced dataset. Diabetes is a target variable we're trying to predict, and we can see that there's only 4,294 data points for people with diabetes, but there's 40,087 data points for people without diabetes. Balanced data sets like this can impact the accuracy of the model being trained, so later on we'll use a technique called oversampling to lead to a balanced data set. Smoking history is a categorical variable which has a value never or current. Here we're calling get dummies to turn it into a one-hot encoding. This means we're creating two new data variables: smoking history current and smoking history never. So if someone is smoking currently, smoking history current will have the value true and smoking history never value false, and vice versa if the person has never smoked. Here we're using pop to remove the target variable from the X data frame to place it into a Y variable, and then use train test split to split the dataset into a training set and test dataset. You can see that the training dataset is imbalanced using value counts. We'll use random oversampler and fit resample to result in a balanced dataset. This works by randomly sampling from the minority class until you have equal number of data points for diabetic and non-diabetic. Here value counts shows that the training dataset now has 26,726 data points for both diabetic and non-diabetic. We're now declaring an instance of the random forest classifier and choosing to have 250 decision trees generated. We call fit using the training data to train the model. Finally, we use predict using the test features to generate predictions of the diabetic target variable, and then use accuracy score against our predictions and the known target diabetic values. This outputs an accuracy of 83.1%. You can also call classification report to get additional metrics, again passing in the predictions and the known diabetic test values. Here you can see output of precision and recall. 0 means non-diabetic predictions, 1 stands for diabetic. Precision is a measure of how accurate prediction is. So if the model predicts diabetic, what percentage of these are correct? Recall is a measure of the sensitivity of the model, as in how many of the diabetic values have actually been predicted.